Okay, so this is where we left off in the last one. And I've highlighted an area here that I'm going to use to sort of just copy into the next step. So I'm going to turn off some previews downstream a little. I won't be using these things in this exercise. And I'll keep that active, but I'm just going to take this chunk of code here and just kind of copy and paste it down and start up a new path for this. And then I'm just going to turn off the preview for everything on top here, so you can, select everything, use your mouse button, and kind of blindfold it all. All right, so here's where we're starting off. Here we have these points. I suppose you could actually keep this line on if you like. That way we can kind of see where we're at, and it bases us a little bit. And we'll start with this little chunk here. And now I'm going to add a little bit to it. I'm going to add a third set of points to give me a little bit more control. So I'm going to say 3 in here instead. And then with that, I'm going to have to input another slider, so I have control over those 4 sets of points. And by default, you'll notice that this component, it kind of adds an input for you. You could ignore this if you like, but I like to clean that up and just delete it out because I don't like any empty data pads coming out personally, so I just delete it. Okay, so now we've got, again, we've got a set of 4 points here, as you can see, and I'll play around with these a little bit. Maybe I'll go like 10 here, maybe go up to 20. Bring this one down a bit, and leave that maybe to match the other one. So now I have kind of an hourglass shape that's arising here if you kind of connect the dots in your mind. But let's actually connect the dots. So I'll start to draw now using these points instead of drawing arcs. I'll actually draw some NURBS curves through them. So this will be a little bit of a review from some stuff we've been looking at, especially when it comes to drawing curves through points from the grid. In this case, we're just going to use a set of points to draw a single NURBS curve. So I'm going to head over to the curve tab here and go to spline. You'll find NURBS curve down there on the left, and you can just go ahead and plug each of these in here, like so. So I'll just grab 2 of those and make a little thing of it. A couple little curves out of that. In fact, I think I'm going to increase my values on this just to give me a little bit more shape to it. Yeah, maybe something like that. Okay. The last thing that we need, what I was going to do here was just use the sweep command, give you some sense of the sweep, how that works. It works exactly like it does in Rhino. Basically, it just requires you to kind of control the inputs. So instead of drawing the curves, you'll be constructing them in Grasshopper. So let's go ahead and draw a new arc. But in this case, you only need 1. I mean, you could draw more arcs than that if you want to really control, if you have some reason to have a center arc or even a third to really control the sweep, you can go ahead and do that. You can add as many cross sections as you like, but keep in mind that because we've drawn these NURBS curves, they don't rest, aside from the start and end point, they no longer rest along those points that we have moved off the center line. So you'll need to locate points on this curve in a way kind of like what we did with the center line, but you have to recreate that process so that you can draw arcs that are directly connected to your rail curves. I won't go through that. In fact, I'm just going to kind of show a more simple version, which is to just kind of isolate the first point in series here out of this list, these 2 lists, right? 1, 2, 3, and 4. 1, 2, 3, and 4. And I'm going to draw an arc just at the front here, just at the, on this side. So how do we select a single item from a list? We can go over to Sets, List, and List Item. And the first one we want to select from is that list there, so I'll grab it. You can see that as I select it now, this little point here goes green, and that's because the index here is set to 0, and that's the first point in line, and that's what it's going to output for me. I could do a number of things to this component. I can add a slider here, and I can change those values from 0 to however many things you have, and you can select them independently in line, in order. You can also hit this little plus button here, and you'll select more that way. This is very useful for the next little exercise when we get into subdividing surfaces. But for now, let's just go ahead and keep that by default. We've selected the point we need. Let's select the other point on the other side, so let's copy and paste that and go ahead and take from the other set that was moved in the opposite direction in the Y, and I'll leave a little space in between because we want also this point here, this first point in space. Alright, so we can find that it's either this point all the way from the beginning, or we can go ahead and make a selection from here. So I'll do that instead because I'm already kind of in this space. So here's my first point on the center line, and I'll put that there because now I can kind of go in order. I like to set up the components visually that kind of so that they kind of represent in a way the organization on screen. So boom, boom, boom. And last thing we need to do, actually, I'm going to move this back because really what I want is I want to draw an arc through these 3 points, but they're all in line, so that's not going to work. I have to lift one of them up in space, right? So I need to move one. I'm going to move the center. So I'm going to head over to transform and go to Euclidean move, and I'm just going to move this up in the Z direction. So I'm going to just double click in here, type Z, grab a unit Z vector. And then I can set, I can just copy and paste one of these sliders over. I can reuse that and just keep the values kind of low. Alright, and just maybe put that down to 7 or something, maybe 8. Now I have enough to create an arc in a different way as a cross-section arc. So I'm going to go to curve, primitive, and in this case I'm just going to go with arc 3 point. Right? And it's just going to look for A, B, and C. You put them in order, and it'll draw an arc through those 3 points. So the control you now have over this basically is its height. And this is different than the last thing that we did, right? Because here you're setting an actual dimensional unit-based height to the arc. So if you needed to know exactly how tall this arc was, this is a good component to use because it's you know, it requires you to set a point in space, and that point in space has to be drawn accurately, has to be located. So you'll know exactly how high it is. In this case, it's 8 units high. So whatever your units are. I'm not modeling this to scale, obviously, but you certainly could. Alright, now we can use this set of lines here. Basically, I have 2 rails and a cross-section in order to produce our sweep. So I'll head over to Surface, Freeform, and Sweep 2. The 2 rails are going to be input like this, and of course your cross-section can go into there. The last thing to pay attention to is you may ignore this if you don't need the control over it, but I'll pop it in anyway. But if you change the height input here, the same height Boolean from false to true, it's going to force that space to be either the same height as your original arc all the way across, or it's going to allow the width of the rails between them to set the height. So basically what's happening in this command is that the cross-section curve is being dragged out across the 2 rails, and as it scales, you have 2 options. You can either scale the arc proportionally so that it fits between the 2 new end conditions, so that would mean that it gets larger and thus taller, or you can force that arc to change shape based on the width of the rails, and that's up to you. That's an option that you have within this component. Alright, so that's just a little something there. Now again, you'll have the control over this as you need in a similar fashion that we saw before. You can make changes to the curve shape. So here we're using NURBS curves and an arc to define a surface. Before we used 3 arcs to define the surface. And you can see it's actually quite interesting because the one that has the most dramatic effect is, of course, the first arc, right? So if I change the first points to have to produce this, semicircle that actually it goes beyond its halfway point, now I get a pretty drastic effect because it has to really stretch in order to accommodate the width that comes up in the rail curves, and that's the cross section that we have actually that determines the shape of the surface along with the rails. So that one has the most effect. These are more of a fine tuning. right? Again, kind of talking a little bit about solution space and parametric control over objects. Working in 3D, you have to start with 2D things in order to kind of give those 3D commands enough input to get working. And here we can see that this input here required a couple of rails and a cross section. So again, very similar to the way Rhino works in this case, and it's just a little crash course on designing up a pretty tightly controlled result, but one that still allows you some flexibility with regard to changing its shape later within those boundaries. One last thing that I'll show here while we have a little bit more time is to just talk through maybe just a simple way to think also about using Rhino in conjunction with Grasshopper in a workflow that allows you to make moves in Rhino that have an effect in Grasshopper. So maybe instead, of controlling your outer NURBS curves this way through Grasshopper and sliders, maybe you just simply want to, freeform sketch them out, and then kind of control their shape through control points in Rhino. So let's walk through a process of that. To do this, I'm going to make this as accurate as I could to what I started with. So I'm going to take this set of points here, all right, the first set that came through, and I'm just going to bake them into Rhino for the sake of this exercise because they're not there yet. So I'm just going to go ahead and bake those in, and you can see now that those points exist. And the reason why I did that is because I'm going to go to the top view here, and I'm going to draw a new NURBS curve with the same number of control points, but I'm going to draw it differently. So I'm going to head over to the control point curve command. I'm going to snap to that endpoint there that I just baked, and I'm just going to, so 1, 2, 3, and then 4. Okay. Now this is of course a different form, but when I select that, I have the option now to modify its form using control points, and I'll kind of set it to something that's sort of similar, to where we're at now, but has a different profile. Maybe something like this. Okay, and I'm going to go back to perspective here, and I'm going to grab a curve component over in my parameters tab. So you can grab a curve parameter here and just right click on that and set that curve into Grasshopper. We're not going to internalize this time, we're actually going to leave it live because when we update the control points, it'll update this component really nicely. And then I'm just going to mirror this thing. So I'm going to borrow our first point, which we know was over here, this point, and that's going to be the starting point of our mirroring axis. Okay, so what we need to do is, I guess, set up a plane there, and I think we're going to mirror this over the XZ plane. So I'm going to go to vector plane and XZ plane. Okay, so I'm just going to draw a plane at that. Right, if I zoom in, you'll see that that's going to set my mirroring axis. All right, so that's good. And I'm just going to pull this down over here, and I'll go back over into transform and find my mirror. So that's going to be the first one in Euclidean. I'm mirroring the curve that I just drew along that plane, right? And that's going to set it to the other side. You can see that there. So I have my original and my mirror. So I can now kind of swap out those two rails, one being the live component, the other one being its mirror image. And the cross section could stay the same because I drew, remember that I snapped my curve here to the original point that I had already set up. You could recreate this process, of course, differently, but I was just working with what we already had on screen. To clarify this a little bit, I'm just going to turn off some previews here so we're not getting confused with what's going on. Okay, there we go. So you can see that we have some changes that we've made. The only control now that we have is the height, but actually we have manual control because I can click on this curve, I can click on its control points, and as I move them around in Rhino, Grasshopper is updating. Okay, so you can use Rhino geometry as an input for Grasshopper components. And this kind of, in a way, keeps it live for you. It's a good workflow sometimes when you're just kind of feeling things out. And you need to, there are benefits at times to using, some Rhino based things like curves or other things to basically to kind of basically instruct Grasshopper what to do next. All right, so this is a different level of control, very similar to what we had before, but it's a little bit more freestyle. You know, we're not using numbers in this case, we're just moving things around, so it's a bit more intuitive, maybe. All right, and you can see that, you know, I'm making pretty big changes to those surfaces, to that surface, just by moving 3 control points back and forth. Okay. So a little bit about, you know, using Rhino to control surfaces as well, you know, curves from Rhino and the control points. You know, while we're doing that, introducing a couple more techniques to kind of, first of all, select single items from lists as a way to kind of slow it down and in a way, kind of a review from even just last week's work. All right, so you'll see that we haven't introduced too many new components here. A lot of the stuff that we covered in our more abstract 2D exercises are being reused. They're just being reused differently to produce objects in 3D. And in the next sample, we'll kind of build on this and add a bit more sophistication to the surface. Again, as a way to kind of talk through data trees now, kind of how data trees sort of arrive by default, just through, you know, basically making multiples out of single things. And you know, from there, we'll talk a little bit about grid-based design in 3D, so that you can use a relatively simple logic of basic surface subdivisions to create, you know, to basically orient objects in space and to control an array of things across a surface, regardless of its form. All right, so we'll head into that next example once you're through with this, but this is all for this one.